Okay, so returning to this problem here, which is case 3, 2, 3. We got down to this one, and then we said, oh my gosh, what is this? This looks very similar to tangent inverse. But when we do tangent inverse, the derivative of tangent inverse x with respect to x is equal to 1 over x squared plus 1. So what is the problem? The problem is that there is this 4 there, okay? So we're going to do some manipulations, okay, to fill in finally the antiderivative, this spot right here. So right now we're going to work with this, okay? We are going to take 1 over x squared plus 4 dx, and we're going to kind of get it in this form. So how we do that? I want to get this 1, I want to get this 4 into a 1, okay? So I'm going to go 1, I'm going to divide this 4 by 4. I'm going to divide this x squared by 4, and I'm going to divide this by 4. So essentially what I've done is I've multiplied the numerator by 1/4 and the denominator by 1/4. So I multiplied by a special 1, essentially. So I am not changing the value, I'm just changing the way it looks. So what does this result in? This results in 1/4 all over x squared over 4 plus 1 dx. Now this is annoying, so I'm going to pull that out. 1/4 integral, and I'm going to have plus 1 here. I'm going to have 1 here. Now instead of writing this like this, okay, I still want to have some sort of form like this. So instead of this being x squared over 4, what is the square root of x squared over 4? It is x over 2. This is being squared. So if I were to do the antiderivative of this, that x goes in that spot. Now what is being squared? This x over 2. So what is going to be the antiderivative of this? The antiderivative is going to be 1/4 tangent inverse of x over 2. But we cannot forget the chain rule. So let's say if I did take the derivative of this, ignore the 1/4, if I did take the derivative of this expression, I would end up with this expression, but I would have multiplied by 1/2 because of the chain rule. So what do I need to do? I need to divide by 1/2, right? So I need to divide by 1/2 because that didn't take place. And then plus c. And so what would I end up with then? I would end up with 1/2 tangent inverse of x over 2. That is what I would have. And so therefore that is the antiderivative of that portion right there. So this is going to be 1/2 tangent inverse x over 2 plus c. And I'm going to get rid of that box. And that is the conclusion of our integration by partial fractions, case 1, 2, and 3, with doing this. All right.